So questions 24 and 25 for the Econometrics final review involve definitions. So for the first one, explain what is meant by the following: a double log model. It's a model where the dependent and independent variables all enter natural log form, and thus all the coefficients can simply be interpreted as elasticities or percentage changes. For a log-lin model, the dependent variable enters in natural log form, but the independent variable or variables are in linear form. An example of that is the growth model, where time comes in linearly, but the output level comes in natural log form. Okay. Now, an interaction term is where an independent variable is formed as a product of two other independent variables, such as x1 times x2. So for example, if we want the slope of a regression of income on education to differ by gender, we would regress income on education and gender, and then interact education and gender. For a polynomial model, it's a model in which an independent variable not only enters in linear form, but also in higher degree polynomial functions. So you have higher degree powers, not just one, which would be linear, but also to the power of 2, sometimes, which would be a quadratic model. Sometimes it comes in even higher powers as well. Binary variables are also called dummy variables or dichotomous variables or toggle variables. They're variables that take on values of either 0 or 1, where 1 represents the presence of an attribute and 0 represents the absence of an attribute. They are qualitative variables, so they cannot be quantified on a cardinal scale. And so if we want to hold factors such as gender, religion, nationality, race constant, we would use dummy variables or binary variables. Now, the dummy variable trap means that we can only include m-1 categories if we have m categories for a qualitative variable. So for example, gender has 2 categories, so we would include only one of those on the right-hand side of a regression. Okay, if we include everything, it would lead to perfect multicollinearity, and so if you were to run this in Stata, Stata would automatically drop one of the variables. In a double log model, so for question 25, we need to complete the following sentences. In a double log model, the slope coefficient measures elasticity, or the percentage change, predicted percentage change in y, in response to a 100% change in x. In a log-lin model, the slope coefficient measures the growth rate, if it's a growth model, if time is the independent variable, or the predicted percentage change in y resulting from a unit change in x. The elasticity of y with respect to x is defined as the percentage change in y over the percentage change in x, which can be written in discrete form as the change in y divided by y over the change in x divided by x, or in continuous form as dy over y divided by dx over x. Demand is elastic if the absolute value of the price elasticity is blank, but inelastic if it is blank. So it's elastic if the absolute value of the price elasticity is greater than 1, but inelastic if it is less than 1. If it is exactly 1, we say that demand is unit elastic. If it's 0, it's perfectly inelastic. And if it's equal to infinity, we say that it's perfectly elastic.